The next method of factoring that we will look at is factoring by grouping. Factoring by grouping is an effective method when you are factoring a polynomial with 4 terms. Before you start factoring by grouping, you do always want to check to see if you have a GCF. If you have a GCF, be sure to factor it out and don't forget to include it in your final answer. If you don't have a GCF, then you move on to grouping the first 2 terms and grouping the second 2 terms. Or in other words, you create smaller groups within the problem. Let's take a look at the first example. For the first problem, we are given 3n to the third minus 12n squared plus 2n minus 8. We are going to start by grouping the first 2 terms and grouping the second 2 terms. Now looking at the first 2 terms, we want to determine if there is a greatest common factor. The greatest common factor is 3n squared. In the parentheses, you're left with n minus 4. For the second set of parentheses, we have 2n minus 8. The greatest common factor of the second set is positive 2. And make sure you identify the correct sign when you do this step. In the parentheses, you're left with n minus 4. When you're factoring by grouping, you must always have 2 of the same factors. In this example, our common factor is n minus 4. Once you know that you have 2 of the same factors, you can write your final expression. For this, we have our common factor of n minus 4 multiplied by our other terms, or other GCFs, 3n squared plus 2. And that's it. So just a quick note, the 3n squared comes from here, 2 comes from here, and the common factor, n minus 4, only gets written once. Alright, so our final answer, our final factored form, is n minus 4 in parentheses multiplied by 3n squared plus 2. Alright, let's all take a second and check our work here. Okay, I'm going to go through this kind of quickly. So just to repeat, our answer was n minus 4 multiplied by 3n squared plus 2. Alright, first step, distribute the first term in the first set of parentheses to both terms in the second set. N times 3n squared gives you 3n cubed. N times 2 gives you 2n. Now let's distribute our second term in the first set to both terms in the second set. So negative 4 times 3n squared leaves you with negative 12n squared. Negative 4 times positive 2 leaves you with negative 8. Alright, let's check our original answer again. Alright, and a little out of order, but yes, it is the same, so our work is correct, and we can move on. Alright, number 2. This expression is 8x to the third plus 14x squared plus 20x plus 35. So we're going to start by grouping our first 2 terms and grouping our second 2 terms. Looking at our first 2, we need to determine if we have a GCF. I noticed that we have a GCF of 2x squared. In the parentheses, we will be left with 4x plus 7. In the second set of parentheses, I notice that we have a GCF of 5. That would be positive 5, so take out plus 5, and we are left with 4x plus 7. So once again, we want to double check. We want to make sure that we have 2 of the same factors. In this case we do. We have 4x plus 7 and 4x plus 7, so our work does check out. We can write our final answer as 4x plus 7 multiplied by 2x squared plus 5. If you forgot where this comes from, 2x squared comes from here. 5 comes from right here. Both are GCFs. All right, our final answer, 4x plus 7 in parentheses multiplied by 2x squared plus 5. If you want to check your work, you can use the distributive property.